Yeah, hi everyone. I just want to briefly explain this CICD pipeline that's designed for training AI and fine-tuning AI. So basically what we've done is we've created a multi-container Docker environment. This allows us to break bits and pieces of the network and its training and associated data gathering functions into separate business concerns, really, is the main reason. So this guy grabs the training data, this guy handles the config, and this guy does the training of the actual neural network. Now from here, we've got a Docker Compose multi-container just to orchestrate the whole thing. And we've got an Elastic Beanstalk over the top. Now the Elastic Beanstalk is the AWS infrastructure that actually handles it. We don't have to worry about instances or anything. That's what Elastic Beanstalk's for, is being able to just push it straight there, not worry about it. So that's going to be a really good build server for our AI to build it and train it. So what we want to do here is we train up the initial model on the existing data set within the Elastic Beanstalk environment. Now, because this is all done on Docker Compose, it's really easy to strip this back a layer, and we can do this locally. We can use something like Jenkins. There's a lot of ways that we can actually do the initial training without having to go to Elastic Beanstalk. But for now, this is what we're doing. So basically, we've got an output section. So once the neural network has finished training on the existing data, puts it into this bucket, and then this Lambda function decides where it has to go. This will change applications. So I haven't fully integrated this with anything. It's just one line of code to say, hey, oh, off you go. We've clicked on something. All right. So that's the delivery section. The integration section, we've actually got GitHub Actions is the main kind of source code integration that we have. So when we make a push to GitHub, GitHub tests our source, make sure it's all fine. This is completely decoupled from what goes on in Elastic Beanstalk. So it kind of allows a separate team to be able to work on the source code, a separate team to be able to work on this, separate team to be able to work on the actual model itself and the layers. A lot of different things. So also in this section, we have this is kind of like a delivery of training data, I suppose. So we've got three client applications here. We could have many, many client applications. Basically, in these circumstances, they will be producing data that's going to be used by the neural network for training. So they feed their data into this bucket. This Lambda function actually decides whether the batch size is big enough. So we upload 1, 2, 3, 4, 5, 6 images. We got to wait till we hit 1,000 or 10,000, and then we actually feed it into the network, because it's not worth booting up this whole environment and trying to train it on like 1 or 2 images, which is why we do it in batch. So once we get the batch, we send it into training data. This is managed by its own team, neural network. Yep, grab this training data in a decoupled manner. We also train up the model, get the old training data or the old training results at least, and we compare the new results to the old results before we push it to this bucket. So this actually, what this does is it proves that the model hasn't regressed. So we want to actually see an improvement in the model. Just like anything, we don't want to deploy it if it hasn't improved. So if it has improved, we send it to the bucket. The bucket is the source map to a Lambda, and that Lambda will be able to easily deploy to anywhere because it's a Lambda. So that's basically my pipeline. The thinking behind it is that we can, very easily modify this neural network, really at the source code level, to use different layers, to use different training weights, to use all kinds of different things. We've got our config as well, which is pretty much hyperparameters. And that's basically it. So I hope that this has been helpful, and I hope that this decoupled CICD for neural networks could actually be used in uh, something.